All right, here we go. We're going to start talking about, first of all, before we go into the notes, our fourth term project. That is a white piece of paper you picked up. It was just one, or a two-sided white piece of paper. I meant to do it yellow. I'm sorry, it's white. You might lose it. Just make sure you don't. Okay? We're going to talk about what you're going to do here. So on the final project, we're going to use this as a review assignment. You're going to be asked to break up into groups of 1 to 4. You can choose to do it by yourself. If you don't want to rely on anybody else for the project, that's fine. If you want to work in a group, you're going to have to make sure you work as a group and everybody pulls their part. Okay? You choose. Your job is to look at the takeaways. You had the packet of takeaways, remember? Core idea 1, 2, 3, whatever. And pick a topic that you'd like to review with the class. Get your topic approved, quick, because once a topic is, our standard objective is gone, it's gone. So some examples I gave you on here, these are not all of them that you could choose from, but there's some, would be, I want to do something with nuclear. That's standard 1, objective 1 to 3, and standard 2, objective 2. Okay? Or maybe I want to do something with thermochemistry. I'd write those down. Okay? I put you up here. Okay? You choose right here. Okay? Your group choose. Then come get it cleared from me today. Come on. Of course, it goes too fast. So once you find your topic and your standard and objective, you're going to write it down. You're going to get a stamp from me. I will next week, I'm going to give you a whole week to sort of think, okay, what kind of things do we want to do? You have to do a minimum of 30 minutes. Okay? If you want more, I've had groups take a whole period because they want to go outside and do some kind of activity, or they want to go move to the lab and do something, or they want to bring somebody in. Okay? So depending on how much time you need to tell me, and then I'm going to break it down as to what day your actual presentation is. Okay? Who's in my group, and their phone numbers or email or some way to get a hold of them. Okay? Make sure you get that before you leave today. Use your imagination. You will need to make or download a video. YouTube will not run at the school, so if you want to make a video or if you want to use a video that's up on YouTube, you're going to have to download it first and then bring it in. Okay? PhET is also a great option to look for simulations because you're going to have some kind of simulation. Make it fun. It's supposed to be a fun review. Your group will have 30 minutes to present. If you think you need longer, again, I'm going to ask you next time, okay, do you guys think you're going to do it in 30 minutes? Or are you going to need more? You know, how much more time do you think you'll need? You'll need to have, if you have more than one in a group, remember the percent participation is going to equal the percent of your final grade. Okay, so not only how well you did, but how much you participated. So in every part, every member of a team needs to be participating. Okay, does that make sense? Because I'm all about this. Nobody's going to get credit for not doing anything. Okay? All right, so the next part here, it's going to go forward. This side right here that we're still looking on, this is for you to divvy out the different parts and who's going to be in charge and who's going to be the helper. So the presentation, everybody's got to be involved in that. I'll tell you right now, everybody's got to be involved. You got to help present. You got to make it fun. The content, who's going to be the one that's going to check off, yes, we did that, yes, we did that, yes, we covered this. We covered everything we needed to. Who's going to be in charge of the PowerPoint or Prezi or video that we make, okay? And who's going to discuss what parts of it? Who's going to do a demonstration? You need to make sure you clear the demonstration with me. If it's one that uses chemicals and you want to use some of the chemicals in the back, that's fine. We need to go over it first. We need to make sure it's safe before we do it, okay? Video simulation. These two cannot be the same, okay? So the video simulation is where you are showing something happening, okay, or simulating something happening. It's not the presenting of the core content stuff, okay? So like, for instance, one year I had a student that her dad worked at a plastic mold thing, and she wanted to learn about that more and go into bonds because it was with bonds. So she took and videoed what they do and had her dad explain it because she couldn't take the class there. Does that make sense? Okay. Job jobs. Let's just go there. Okay? You can't say chemist. You can't say scientist. You got to give me a job. What? Chemical engineer. What kind of chemical engineer? There's several kinds. So you got to be very specific, okay? So really get down and think a little bit more about that. Then you've got reference page. You need to at least look 5 places. I'm not going to hold you to so many books, so many websites. You need to tell me 5, okay? And they need to be cited. You need to show me, if you've got a team, that you're working well together and that you've coordinated stuff and there are things that everybody's in charge of. And then, of course, there's the extra credit you can add here with if you bring goodies. Now, the goodies have to relate to the topic that you chose. They can't just be goodies to have goodies. Okay, we're having Twinkies because we talked about light. That doesn't relate, okay? So it's got to have some kind of relationship. And then you got a total test score. So you could end up with 110% on your test, which would help on other tests if you do a little poorly. All right? So on the back side is where I'm going to grade. So today you're going to get 2 stamps, hopefully. One on the front, one on the back. The back is what I'm really going to be looking for. Did you approve your topic? Okay? So you want to get your topic approved. You're going to fill everything in except for presentation date. I'm going to give you that next week. Okay? Underneath that, you're also going to be putting people's names that are in your group and some abbreviations, and you can put where they're supposed to be helping. This right here part, this is what you're going to fill in right before you give it to me. This is your grade of your people in your group. You don't have to share this with anybody else, but this is your true grade. If somebody really was a slacker and did absolutely nothing and was part of your team, give them a 0%. That's going to go into their grade. Okay? If they didn't do anything, they shouldn't get credit. Okay? All right. This next part is a table that I'm going to fill out as I go through. You can put out here who was supposed to participate if you want to. I'm going to say who in here did participate and what I actually saw. Okay? And then that's the end of that. Any questions on your project? Okay, it's 100 points towards your test scores. Yes, ma'am. It will be due in about middle of May, end of May. Okay? So you got, yeah, right before school gets out. Okay, grab out your acid-base notes. We're going to start on those. You picked up 2 other papers as you came in today, your acid-base notes and your assignments. Yes, ma'am.
Oh yeah, does it have to be 30 minutes long?
It needs to be 30 minutes minimum, yes. By the time you get through all the things that I've asked you to do in that 30 minutes, it actually goes fairly fast, it feels like anyway. Okay? All right, so we're on to acid base. I love acid base because it's around us everywhere. It's so relevant. It's around us everywhere. So let's talk about it. The first thing that we need to do is do some definitions. And we need to know what a hydronium ion is. A hydronium ion, I got to pick my favorite thing here. A hydronium ion is H3O+. A lot of times they shortcut it and just write H+. It means the same. Okay, so a hydronium ion is a water with an extra hydrogen, or just a hydrogen by itself. A hydroxide ion, we've worked with this before when we were doing formulas. That's just OH-. Okay, now we're going to talk about 2 different branches of thought when it comes to acid-base, but there's really 3. And if you go on to CE or AP, you'll talk about this outer one, the outermost. I like to think of it like a bullseye. They cover all the acid bases underneath them. So the biggest, the outside one, we're not going to talk about, is called Lewis. Then we go Bronsted-Lowry, and then we go Arrhenius. We're going to start in the center of the bullseye and talk about Arrhenius first. So Arrhenius basically said, okay, acids are going to donate an H+. And bases are going to donate an OH-. That makes it real easy to look at something and say, oh, if it has an H, it's going to be an acid. If it has an OH, it's going to be a base. Makes it fairly easy. Give me a second because I see you writing furiously. Okay, so we're going to go on. Okay, so, oh, wait a minute. I've got water plus water. It gives me a hydronium and a hydroxide. What in the world? I can add water to water and get an acid and a base. This is known as amphoteric. That means I can act as an acid or a base. So have you ever had those friends that can be with different groups? They can be with a group that's like really crazy and out there, and they sort of calm that group down a little bit. But then they go to another group, and they're the crazy wild one, and the rest of the group's trying to calm them down. Ever been with a friend like that? That's sort of like these amphoterics. They say, you're really acid, so I'm going to be the base and mellow you out, neutralize you a little bit. Oh, no, here you guys are the base. I'm going to be the acid, and you guys got to try and neutralize me, okay? All right? So what we're doing here is one of these has to be the acid. One acts as a base. Over here, this is going to be my conjugate base, and we're going to talk about this in a minute. And this is going to be my conjugate acid. What in the world am I talking about? Conjugate just means if I went backwards. So when I have a double arrow, it means I can go forward or backwards. So if I go forward, I just talk about acid or base. But if I'm using the reverse reaction, then I talk about conjugate acid and conjugate base. Okay? They come in pairs. So this was an acid. It gave up its hydrogen and became the conjugate base. This was the base. It grabbed a hydrogen and became the conjugate acid. So they sort of relate to each other. Now, the equation right below that is just another way of saying the same thing. Only we're just looking at water falling apart, it looks like. But it's actually saying, okay, it actually split up and gave me a hydrogen and a hydroxide, an acid and a base. It's just saying it is amphoteric, meaning it can act as an acid or it can act as a base, depending on whose friend it's with. Okay? And there are a couple of amphoteric compounds that we're going to be working with a little bit later. Water is probably the most common. Okay? So going on here, what's the top one? Is it an acid or is it a base? And how do you know? Top equation, does it tell me it's an acid or a base? It's acid. Oh, I got the H+, so it must be an acid. I have a hydrogen, right? By Arrhenius, if I have a hydrogen, I'm an acid. Okay, what about the bottom one? It's a base because I have the OH, which Arrhenius says is going to be an acid, or I can look here and say, I've got an OH, so it's a, sorry, base. So it's a base. Okay? Okay? All right, let's go forward a little bit more. Ooh, on this one now, I've got to label the acid, the base, the conjugate acid, and the conjugate base. So going forward, which one's acting as the acid? Going forward, which one is going to give up a hydrogen? Water gave up a hydrogen going from here to here. So I'm going to connect them. That's known as an acid-base pair. This one is going to be my acid. Okay, and I'm changing colors. Sorry. So the other one has to be my base. So this is my base. And going from this side to this side, it gained a hydrogen, right? All right, now think reverse. This would be my what? Conjugate acid, good. Okay, and then this one would be my conjugate base. Because going in the reverse direction, OH minus gains a hydrogen. And NH4 loses a hydrogen. Okay, the ones that I've connected, the ones that are connected with a blue arrow are a conjugate pair. The ones that are connected with a green are a conjugate pair. Okay, acid-base pair. So let's look at another one. Let's see if you can label this one without me touching it. You guys label it. See if you can label it all the way through. We'll pause the video, so go ahead and label. I'm going to start at the back with Adrian. Give me one thing to label up there. Tell me one thing to label. This is a what? Acid. It's an acid. Because it gave up from this side to this side, it gave off the hydrogen. Okay, Brody, give me something else to label. Okay, this is an acid. What kind of acid? Good, conjugate. Okay. Adam, give me another one. H2O here acts as a base. Good. Okay. We got one more. What kind? Conjugate base. There we go. Okay. What two go together? No, she's got to do it. She's got to do it. Good. Okay, what's another one that goes together? Okay, so you've done it. You've done it. Was it hard? Okay, let's try another one. This one has a couple errors on it, so make sure you're looking up here to fix the errors first and then do it, okay? There's a couple errors on your lab or on your notes. So go ahead and take a few. That's not good. Okay, so we're going back and identifying Bronsted-Lowry. Bronsted-Lowry base accepts a proton. The Bronsted-Lowry acid donates a proton. Okay, so those are our definitions of Bronsted-Lowry. For some reason, I've got to go back and put that slide in. I don't know where it went. Okay, did everybody get that down? So we're back up. It should be right underneath number 4. Okay, we okay to go forward? Wait, no. H3, H2PO4 with a -1. So that 4 should be down as a subscript. Okay. All right, so we went through all these. Okay, now, what if I'm just given a compound and I'm asked to say, okay, here is the acids, give me the base for that acid. Once it donates its proton, what base does it become? So donating a proton means getting rid of a hydrogen and its positive charge. So this one already had a positive charge, right? So if I take away a hydrogen, it becomes one less hydrogen, so just HF and no charge.
So we're finding the conjugate acids?
The conjugate base for these acids. These acids are going to give away a hydrogen. So once they give away a hydrogen, they become a conjugate base. Okay, so if this one gives away a hydrogen, what's it going to become? HSO4, but it's lost a positive, so it's going to be a -1. What about HNO3? NO3 minus, because I took away one positive. This one already had a positive, so if I take one positive away, it becomes neutral again. Okay, so what about this one? Good. Okay, so now let's look at some bases and predict its conjugate acid. So, okay, I have bases. What's going to happen to be a conjugate acid? It's going to gain a hydrogen. So if it's a base, it's going to gain a hydrogen to become a conjugate acid. So this one, to gain a hydrogen, it's going to become what? Okay, what about this one? Brody, what's this one going to become? It's a base. Okay, HPO4 what? Good. I know, that's awful, isn't it? Okay, what about this one? Right, this one right here. HSO4, what charge? -1. Now this one is written organically. I could write it inorganically like this, C2H3O2 with a minus. It's acetate ion. So if you go on to organic chemistry or you go on to CE chemistry, we do some organic in there. It's written like that because when it's put together, it's actually put together with hydrogens like this. And this shows me how it's put together, like this. Okay, so it shows me the structure by writing it that way. So that's what we do in organic. We do work with structures of compounds, carbon compounds. So here we have the acetate ion. How would I write it as its conjugate acid? Okay, I would write it this way inorganically. Organically, I would write it like this. Doesn't matter. Because what happens is the H comes in right here. So that I have to show where it's at organically. Right. That's the acetate ion. That's what this thing is right here. Okay, the reason why it doesn't go to H4 is because this is a group that hangs together and the hydrogen just comes in and it comes in right here. Whoops, that didn't work. I got pink, it's okay. It comes in right there. So it just hangs with the group. It doesn't really invade the group. Okay? All right, let's go on to the next one. So how do I know if I've got a strong acid or a weak acid? Strong acids, 100% ionize. 100% go to the products. Nothing's left in the reactants. 100% go to the products. That's what a strong acid is. On the other hand, a weak acid has this double-sided arrow, meaning it can go forward and it can go backward. It didn't like that. Still didn't like that. Okay. It can go forward or backward. And it usually only goes 1 to 5% ionization. That means it only goes forward 1 to 5% to the products. So weak, there's not much of the products there. Okay? All right, let's go forward. So what do you think is going to happen here with the bases? %, ionized. 100% goes to the products. What about weak? 1 to 5% goes to the products. Okay, so anytime I see a double arrow when I'm working with acids and bases, that tells me, oh, I've got a weak acid. But if it's a strong forward arrow, then I know it's a strong acid or base. Okay? Let's go forward. All right, there's some other tricks that I'm going to tell you or show you so that you can identify bases and acids. The first one's with the bases. It's sort of like in a Tetris pattern. Okay? We start with lithium and go over and down. Now, some people include rubidium and cesium, but rubidium and cesium are really hard to find, and they're really hard to have very much of, so most people don't include them. So we just use the Tetris pattern. So what is in there? What have we got in there? We've got lithium, potassium, and sodium. Oh, I got them backwards. Sodium and potassium, and then we go across to calcium, strontium, and barium. Okay? These are bases. They're going to add to OH. So lithium, sodium, and potassium are in the +1. Yes, Brody. You'll feel slippery, and that's your skin sloughing off. Have you ever felt bleach? You know, if you get bleach on your fingers, it will feel really slippery, and that's basically because your skin's sloughing off. Your fingerprints are going away. As long as it doesn't go too deep. Base is mellow as far as you've got a little bit of time to get it cleaned off before it does a lot of damage. Acids are right away, but bases are harder to get off. So, okay, these are the bases that are the strong bases. We're going to call 6 strong bases. First column, +1. Stay with me, Brody. First column, +1. Okay, so lithium hydroxide, sodium hydroxide, potassium hydroxide. Second column, +2. So I need twice as many hydroxides. So calcium, parenthesis, OH, parenthesis 2. Strontium, hydroxide, parenthesis 2. Barium, parenthesis, OH, parenthesis 2. Okay, so we've got 6 strong bases. Now, on this other side, I call it my swooping down. There are 6 strong acids too. There are 3 binary acids. Binary means what? 2. So there's 3 binary acids that have hydrogen and just something else. There are also 3 strong oxyacids. Okay, guys on the back row. It's a warning. I let you pick your seats this time. Guys and gals. Okay. If I still have issues, I'm going to make the sitting chart again. Okay. All right. So there's 3 oxyacids, 3 binary acids. The swoop on this side over here is the oxyacids, and it goes here, here, and here. Let's fill them in with what's there. So this is nitrogen, this is sulfur, and this is chlorine. Now you'll notice I left some room because oxyacids have oxygen. So this one is NO3 minus, this is SO4 2 minus, and ClO3 minus. So my oxyacids are going to be HNO3, which is nitric acid, H2SO4, which is sulfuric acid, and HClO4, which is perchloric acid. Has one more oxygen than chloric acid. Now, along that, that's the swoop. That's my ones that have oxygen. I now do the down, and the down hits the chlorine again. So I'm going to just hit the chlorine, and it goes down to here. So it includes bromine and iodine. So for this one, chlorine is also by itself. So we have HCl, which is hydrochloric acid, HBr, hydrobromic acid, HI, the friendly, unfriendly acid that will eat you alive, but still tell you hi. Yes? These ones are binary acids. So these 3 right here are binary. And the top 3 are oxyacids. Now notice how I named them different with the oxyacids. This is a review of how to name acids. Remember on the top ones, the H just told me it was an acid. I looked at the back end, which was a nitrate. Remember if it polyatomic ended with an 8 and it went into my stomach acid, ick. So we changed the ending to ick. If it ended in ite, it was like a fight, OS, we're going to get in a fight. So it changed to OS. Okay? Binary acids, you always see hydro, whatever the other thing is, ick and acid. So hydrochloric, hydrobromic, hydroiodic. Okay? So these are listed for you on that chart. So hopefully you identified that as I was doing that. It also gives you the names. So if in case you've forgotten how to name, you can go back and look at naming because that's going to go through what we're doing. Okay? All right, so this is the end of this lecture today. So what I need you to do is work on assignment 1 and work on your review packet that you got from last time. And during this time when you're working on your own, you need to come up and check off your term project. Just as a real quick reminder though, because I had a whole bunch of kids ask me this last time, will you turn on your assignment number 1, page 2, I think it is. Back number 5 and 6. We're going to look at those really quick. 5 and 6, look real quick. So number 5, everybody look on your assignment number 5 real quick with me. A is HClO4. Okay, all you have to do here, okay, is say, oh, if I add that to water, what's going to happen? If it's a strong acid, one of the 6 from the other page, I use 1 arrow. If it's not one of the 6 acids from the other page, I use a double arrow. And who's going to be the acid? Well, the one that's the strong one, right? So this is going to be my acid. This is going to be my base. So my acid's going to donate a hydrogen and become ClO4 minus. And my base is going to receive it, H3O plus. Now, skip down to number 6. Okay. On number 6, I'm going to do C. So on 6C, it says BaOH2, right? And it is a strong base, right? It's one of our strong bases. Now, on this one, we don't add the water because most of the bases come as solids. And so we add them to water. What happens to them? They become their ions. So we're going to say, okay, I'm adding this solid to water, and I can even put water above here if I want to. I don't have to. But it becomes barium ions, cute little ions, a cute little ion, it just means aqueous, dissolved in water, and 2 OH minus aqueous. So you got an example there. Now do me a favor and flip over the page again. And it is number 10. Number 10, we had some kids that were also struggling with number 10 because they've forgotten how to do OI. What is OI? OI, I'm in chemistry. What does OI mean? Outsides and insides. Okay, so I'm going to do the hard one with you. D. Magnesium. What is it? Magnesium hydroxide? Plus, what is the phosphate? H3PO4. Okay, and this one is a strong one, right? 2 strongs. Okay, so outsides, OI. Magnesium's going to go with phosphate as a group. And insides, hydrogen's going to go with hydroxide, right? Okay, well, magnesium, I know this is a -1 charge, and there's 2 of them, so magnesium has a +2. Phosphate, there's 3 hydrogens. Hydrogens each have a +1, so that means phosphate's a -3. So if I put magnesium with a +2 and phosphate with a -3, they're not going to add together to equal 0. What do I need to do to fix that so they add together to equal 0? How many magnesiums do I need? 3. How many phosphates do I need? 2. Okay, plus my insides. Hydrogen's a +1, hydroxide's a -1. H and OH make all the time water. Yep, water. Okay, so now I can erase all my helping things here, and I can balance side to side. So I have 3 magnesiums on that side. I need a 3 here. I'm doing the hardest one with you. Okay, I have 2 phosphorus on this side. I need 2 on this side, so I'm going to put 2 there. I now have 8. I'll not leave the oxygen to last. How many hydrogens do I have? I have 6, and 6 is 12. I need 12 over here, so that's going to have to be a 6 in front. That leaves me 8 plus 6 is 14. 8 plus 2 times 3 is 6 plus 14. we're good, right? 8 plus 6 is 14 again on the other side. Okay, so that's balanced and we're done. Just remember OI. Outsides go together, insides go together. You got to know the charges. It's back to bringing everything together that we've already learned. Okay, we got to remember it all. It's coming down. It's coming down the pike. Okay, time is yours to work. And if you've got your project idea, come on up.